I have to admit, I love binomial products. I love mathematics, and if that does not sound seriously sad at the opening of video, nothing is. Hi guys, I'm MaffsGuru. Welcome to my channel. It's good to see you here. Yesterday I'm dealing with the products of binomials, and I'll explain what that is in a moment. If you're new to my channel, it's really good to see you. Thanks very much for stopping by. If you do me the honor of clicking that red button or whatever that red arrow is pointing to, it's great. It just lets me know you're actually watching the channel and that I'm not sitting here on my own talking to myself, which is what it feels like most of the days with my 7 subscribers undoubtedly in Hull. So greatly appreciated. But you're here for the maths, aren't you? Or at least I hope you are. And by the end of this lesson, and there's a red arrow telling you very much what I want to try and achieve, I want you to know what a binomial expansion is, to be able to use the idea behind these to multiply sets of brackets. Now, not just ordinary brackets, brackets with surds, which is very much what this video has been dealing with. To be able to simplify where possible binomial expansions into its simplest form. And by that, we're just going to use like terms, being able to sort of add things together that are the same. Now, obviously, in a previous video, I've dealt with all sorts of things on irrational numbers, surds, adding surds, multiplying surds, blah, blah, blah. If you haven't watched them, they are fabulous, and they're going to let you sort of understand what's going on in this video. But don't worry about it. I'll try and do what I can to fill in any gaps. Now, the distributive law is effectively when you multiply two things together. That's what the distributive law is. We can use these with these things called binomial products. And what is a binomial product? Well, generally speaking, it's where we have two expressions multiplied together. Bi means two, and nomial means gnomes. Gnome, do you see the gnome? No, still not funny. I know, all right, easy. But basically, it's when we multiply two expressions together. And we're going to see this a lot over the coming months and years because we do it all the time. And it doesn't get much harder. Once you can work out and do this sort of stuff in your head, I can pretty much promise you, you'll be a gun at mathematics. So, as I've said here, an example of a binomial product would be x plus 3 and x minus 4. That's just one example. Why? Because there are two things, two expressions multiplied together. And yes, between those brackets, there is a kissy-kissy. And if you don't understand what I mean by kissy-kissy, you've missed out. There is a video coming on all of this delusion I have in my head with regards to, things kissing each other. Sounds wrong. Later on in this course, we'll be looking at binomial expansions using Pascal's triangle and all sorts of stuff. And there's already a video loaded relating to Pascal's triangle. But let's go back to the very beginning, because it's a very good place to start, as I believe The Sound of Music stated. Now, normally when we multiply two things together, we actually follow a pattern, all right? But we can do it the hard way or we can do it the easy way. Now, when we were in year 7, we actually made things really challenging for you, and probably year 6, because we said, right, multiply 23 and 35 together. And I can guarantee, I've done this recently with a year 6 group, and chaos, absolute chaos. And I'll tell you why. There's an easy way and a hard way to do it. And in junior school, for some reason, we taught you the hard way. Yeah? So do you remember this? So we would have said, right, 23 times 35 is equal to, oh yes, you've got to write it out. So 23 times 35, and you did the line and a little kissy-kissy. And then you were sort of like, oh, I've got to multiply some of these numbers together. And you were just like, oh, I'll choose the 5. And we then taught you to do 5 times 3, which was 15. Now, I always carry the 1 down there, and I know lots of people in Australia get very upset because that's supposed to go on the top, and I'm like, no, it isn't. We'll put that argument to rest. Then we do 5 times 2, which was 10, and we add the 1, which gives us 11. And then we rub out that little value there because we don't want it to get in the way. And then we go, right, what do we do now? Well, this is where you put that random 0 in. You go, oh, I put a 0 in there. Now, when I say to you why, most kids go, well, that's just what we were told. It's just random. Why would we put a 0 in? Anyway, and then we continue. And we go to this 3 times 3, if we're lucky, is 9. And 3 times 2, if we're lucky, is 6. And then we randomly add these two things together. Why? Because we're more learning a pattern than we're learning maths. And we've got a 5 there and a 0 there. And I know we've carried the 1 below. And all your people are screaming at me going, you can't do that. 6, 7, and 8. And lo and behold, we come up with 805. Do you know what? There is a much easier way of doing this. And I'm about to show it to you now. Are you ready? And actually, the way we're going to use this is to split up 20. What did we have? So we had 23 and we had 35. Now, I'm going to tell you that 23 is the same as 20 plus 3. And 35 is the same as 30 plus 5. And you're going to say, you've not told me anything new there. But now what I'm going to do is I'm going to draw a grid. Yeah. Now I know there's lots of other ways of doing this type of stuff, but I'm going to write 20 there and 3 there, and I'm going to write 30 there and 5 there, and a little kissy there. And all I'm going to do now is for each row and column, I'm going to multiply where they meet, where those two numbers meet. So this one here, this first box here is 20 times 3, which just happens to give me 600. See, I can do that in my head. 2 times 3 is 6, add the 2 zeros. Again, random. 30 times 3 is 90. 20 times 5 is 100. And 5 times 3 happens to be 15. And all I'm now going to do is add those together. I've got 600, 100, I've got 90, and I've got 15. And I can add them together in any order I like, as long as I don't double add. So that's 700, that's 105, and add them together gives me 805. Now, I don't know about you, but that to me feels so much easier. And it actually works with all sorts of numbers. If I had 715 and I wanted to multiply that by 23, I would do 710 and 5 and 20 and 3. And I would create a grid that would have 3 across and 2 rows and just exactly the same thing. Now, why is this important? Because actually we can use this to multiply out binomial products. And again, I'm going to do it 2 ways. Now, as I say here, I was taught FOIL, which is first, outside, inside, last. Come back to that in a moment. But we could use exactly the same method to now multiply these 2 brackets together. Because I've got an x and a plus 3. I've got an x and a minus 2. So using this grid style, all I'm doing is breaking up my binomial product into x plus 3 and x minus 2. And now, once again, multiplying rows and columns where they cross. This one here is x times x, so that's x squared. This one here is x times plus 3, which is plus 3x. This one here is x times minus 2, which is minus 2x. And this one here is minus 2 times plus 3, which is minus 6. And what do? Well, I add them all together. That's what I did previously. That's what I did with this one here. I just added them together. And all we've got to do is make sure that we add together our like terms. So I will do it under here. So we get x squared plus 3x minus 2x minus 6. Well, there's only one x squared term, so that's gone. We have a plus 3x and a minus 2x, which gives me plus x. So those are those gone. And minus 6. And ladies and gentlemen, I have multiplied out those brackets using something that's relatively simple. Now, the way I was taught it was x plus 3 and x minus 2. Now, FOIL stands for first, outside, inside, and last. So what it means is multiply the first 2 terms together. So there are my first 2 terms. X times x gives me x squared. Then it says multiply the 2 outside terms together. And by that it means this. So there's an outside term, which is the x, and a minus 2 is an outside term. Multiply them together gives me minus 2x. Then the inside 2 terms, plus 3 times x gives me plus 3x. And then the last 2 terms of the brackets, plus 3 times minus 2 is minus 6. And what do I get? So I get x squared minus 2x plus 3x is again plus x and minus 6. Now, it's totally up to you what you use. Nowhere in maths does it state the way you have to do this. It's whatever you decide is the best way for you. And basically, we can use this idea to multiply surds or all sorts of different things. All right, so let's do both ways to do this example here. So I've got 4 plus root 2. So just drawing my table, there's little times there. So I've got 4, and I have to put plus. Let's make these lines shorter so it doesn't look like I'm actually doing that. 4 plus root 2. Now you have to put the plus and minus signs in because it makes a huge difference. And what have I got here? Root 2 and minus 3. So all I'm going to do now is multiply these together. So 4 times root 2 is 4 root 2. Oh, change your pen color. Root 2 times plus root 2. Now again, if we had root 2 times plus root 2, well, I don't have to put the plus in because a positive times a positive, because that's a positive as well, is a positive. And we know that root 2 times root 2 is, yeah, it's 2. When you multiply a surd by itself, you actually get rid of the square root sign. And there's a video on that for you to have a look at. I'm now at minus 3 times 4, which is minus 12. And I've got plus root 2 times minus 3, which is minus 3 root 2. So rubbing this out to make life a bit easier, all I do now is say I've got 4 root 2 plus 2 minus 12 minus 3 root 2. Now we're going to collect like terms. So I've got 4 root 2s and I'm going to take away 3 root 2's, which gives me a root 2. I always do my surds first. Then my numbers, I've got plus 2, minus 12, which is minus 10. So root 2 minus 10. How does this work with FOIL? Right, well, we've got 4 plus root 2 and root 2 minus 3, which gives us, so first, gives me 4 root 2. Outside, which is 4 times minus 3, which is minus 12. Inside, root 2 times root 2 gives me 2. And a positive gives me a positive. And root 2 times minus 3 gives me minus 3 root 2. Collecting like terms again. 4 root 2 minus 3 root 2 gives me root 2. And minus 12 plus 2 is minus 10. And we end up with exactly the same answer. Yay! What about this example? Same thing, really. I'm just going to do it now with FOIL. If you want to use the other method, that's fine. But I'm going to start using FOIL. Right, so 2 root 6 minus 1 times 3 root 6 plus 5. Rewriting the question. So first, now in this situation, you have to multiply the numbers and then the surds. So 2 times 3 is 6. And root 6 times root 6 is also 6. Because when you multiply a surd by itself, we just get the number underneath it. So that's the first. Outside, plus 5 times 2 root 6 is 10 root 6. Minus 1 times that gives me minus 3 root 6. And minus 1 times plus 5 is minus 5. So 6 times 6 is 36. I'm going to simplify this in stages. 10 root 6 minus 3 root 6 gives me plus 7 root 6 and minus 5. And lo and behold, writing, so I've got some space. 36 minus 5 is what? Oh, let's put the surds first. 7 root 6 and then plus 31. Now, generally speaking, where we can, we'll put the surds first. Now, throwing a curveball. It amazes me the number of people who mess this up. And I'm really, really sorry if this is one of you, but you have to stop it. AB squared is not the same as A plus B all squared. Now, what I'm trying to say by that is if I have AB squared, that is literally A squared, B squared. If I was to multiply this out using FOIL, I actually end up with A squared plus 2AB plus B squared. They are not the same. And so it fascinates me the number of people who will say, and I'm going to do this wrong first, so please don't do this. The number of people go, oh, I know that. That's just x squared plus 9. It isn't. What you've done is you've just squared the first term and squared the second term. It isn't. This is a FOIL question. And my advice to you is always, always, always write this out longhand first. When you square something, you're multiplying it by itself. When it looks like that, the chances are you're going to do FOIL. X times x, x squared, x times plus 3 is plus 3x. Plus 3 times x is a plus 3x, and plus 3 times plus 3 is a 9. Simplify like terms. Do I have any other x squared terms? No. Do I have any other x terms? I should go, I do. And what about my number? Plus 9. Thank you very much. And there is my final answer, which is very different from what some people think x squared plus 9 is. Yeah. Notice you've actually missed out that middle term altogether. So if you do that in an exam, sadly, you will lose hundreds and hundreds of marks. We can use this idea to simplify and expand. Or as my question says, expand and then simplify these things. They've got surds in them. So I see a square term. All right, 3 minus root 2 times 3 minus root 2. And now I'm going to do FOIL first. 3 times 3 is 9. Outside, minus 3 root 2. And again, if you're not sure why that's true, go back and watch the video on multiplying surds. It will help you understand how to do this section. Minus 2 times root 3 is minus 3. Oh, sorry, minus 3 times root 2 is minus 3 root 2. That may well have been what I said. I just can't remember. And minus root 2 times minus root 2 is plus 2. And again, because root 2 times root 2 is just 2. Simplifying this, 9 plus 2 gives me 7. So there's my 9 and my plus 2 is gone. And minus 3 root 2 minus another 3 root 2 is minus 6 root 2. Now in this situation here, I'm not going to write my surd first. Why? Because it's a negative. And generally speaking, we always try and start expressions with a positive. Ramping it up, one last question, and those of you who are being taught me can probably already see the work that I'm going to ask you to do. But here we go. So 2 root 3 plus 3 root 2 multiplied by 2 root 3 plus 3 root 2. FOIL. Multiply the numbers together gives me 4. And root 3 times root 3 just gives me 3. So I'm going to write that down. Outside, I get plus 2 times 3 is 6. And root 3 times root 2. Now, because they're not the same, that's just the same as the square root of 6. Because the 2 times the 3 gives me the 6. We're going to add on the inside, which is 3 times 2, which is 6. And root 2 times root 3, which once again is 6. And then I'm going to add on 3 root 2 times 3 root 2, which gives me 9 times 2, because root 2 times root 2 is 2. Simplify this down. 4 times 3 is 12, plus 6, that's going to give me 12 root 6, plus 2 times that is 18, which gives me 12 root 6, plus 30. Ladies and gentlemen, wow, are you ready for a 40-second recap? Well, with Binomial Products, what did we do? We looked at the idea that it was building on all the previous stuff that we've done before, adding surds, multiplying surds, and we looked at the idea that what a binomial product is. It is where two expressions are multiplied together. We looked at bi and gnomes, and we had nothing to do with gnomes in this particular exercise. We looked at the idea that when we expand products, we can build on maths we should have done properly in year 6. Well, we taught you the horrible way to do it by banging zeros in, but we should have taught you a better way with this grid, because had we taught you the grid, we would have ended up being able to set up these binomial expansions so much easier. There were 2 ways shown, one with a grid and one with FOIL. What was FOIL? First, outside, inside, and last. We looked at surds and binomial expansions, and we looked at throwing in curveballs, the idea that we can actually raise these binomials to a power of 2, and it's always a good idea to multiply them out, or at least write them side by side so that we can FOIL it. Wow. And breathe. Ladies and gentlemen, as is normal, it is fabulous having you here on my channel watching this. If you've enjoyed it, do me a favour, leave a comment below. I'm not sure anyone even gets to the end of these videos, to be honest with you. I don't know what's going on, but if you enjoyed it, leave a comment. If you would, do me the honour of subscribing. That would be great. And if you could let your friends know that this channel is here, I would also be deeply appreciative. I'm doing this for you guys, so yeah, it would be good if people watching. Otherwise, there is a video for you to watch loading. MaffsGuru, see you next time. I'm out.